In here, currently for Team Polar, we're looking at the performance of the cells and we're trying to understand which is better at the lower temperature.
Hi, my name is Magnus, and in a series of videos I'm joining the talented student team through every step of their journey to safely and autonomously gather data in Antarctica. As TNO, we are not just standing on the sidelines. Our team of experts are helping Team Polar turn their wildest engineering dreams into reality, making this groundbreaking research possible. Welcome to our second episode of Road to Antarctica. Today we're going to meet the rover itself, but before we do that, we're going to dive into where it gets its power. Today we're at the automotive campus in Helmond, where TNO has lots of testing facilities, and we're going to go and see how they test batteries and also how they can do that inside a climate chamber. So come with me. This looks a lot like a microwave to me. Can you tell me what it is?
Yeah, so this is our climate chamber connected to a cycler. In here we connect cells and we subject them to different currents, voltages and temperatures. In here, currently for Team Polar, we're looking at the performance of the cells and we're trying to understand which is better at the lower temperature.
And that's exactly what you're doing for Team Polar, and I guess that means you're going to be using lots of low temperatures. What can you expect to happen with a battery at low temperatures?
So the batteries here at low temperatures will probably not be able to release all their energy that they would be able to release at higher temperatures.
Do you think it would be good to get Team Polar in and understand a bit more about the application?
For sure, maybe they can tell us about the temperatures that the batteries are subject to and the environment in general.
These climate chambers are a perfect way to test the Antarctic conditions because as we might go to the South Pole, we have -40°C temperatures, and of course these can simulate that.
So the rover's covered in solar panels, so why do you even need batteries?
You need a buffer to store this energy, and of course batteries are perfect for that, so that we can theoretically drive for an infinite amount of distance.
Brilliant, thanks very much. We're here at the Technical University of Eindhoven, where Team Polar have their headquarters and their workshop, which you can see around us. And we've got 2 rovers and 2 members of Team Polar. Tim, maybe you can tell me a little bit about this mini rover first. What's it called and what's it being used for?
Yeah, so this is the Minicube. That's what we call it. This one has been built in the last 4 weeks. And right now it is used as a testing platform for autonomous sensors and also for electrical. So right now it's a bit empty, there's no sensors in there, but what we will be using for is it for autonomous driving. We put the camera on there and we can test all sensors as if they were on the final vehicle.
And what about this slightly larger one here?
So this was the first prototype, we call it the Ice Cube, and this was tested in Norway as well. So the plan is to have the whole vehicle insulated, because this one is not Antarctica proof. If a wind with like a lot of ice and snow comes in, all these components will get wet. So we have to properly insulate and seal the vehicle.
We'll have the new rover do an expedition from point A to B.
We go from research station to research station, 1,000 kilometers plus.
I can see inside there's like a frame structure. Is that going to be the same kind of design in the next build, or is it going to change a lot?
Yeah, so we see the main chassis here. The next vehicle will ever be one chassis and a big cover as a shell to house much bigger area of solar panels.
Curious about the next steps of our adventure? Subscribe on YouTube and see you next time.